So, welcome to problem decomposition. By the end of this lesson, you should be able to apply Polya's four-step problem-solving process to a given problem. So, this is a system that works really well for whiteboarding problems. It also happens to work well for any kind of problems. It's a generic problem-solving technique. And so it works like this. Step one, clarify the what and the why. So we're trying to understand what the problem is. And there's a couple specific things that you can do to help with that. Then you're going to devise a plan. And you're going to execute the plan. And then the easiest one to forget about is to reflect. Super important part of the process. Can't skip it. So these are our 4 steps. Let's take a like a generic whiteboarding problem. Here's one. Stop it. Write a function that reverses a string. So our first step, clarify the what and the why. So what are some questions you think you could ask that would give you more information about what's being asked for? Hit me.
Wouldn't these be like user stories? Like as a user, I want to be able to do da 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 da.
Almost never. Not in the context of a whiteboarding problem.
Okay.
For better or worse, like these things are completely abstract problems, and they just want to see you solve them.
Okay.
So they very rarely will phrase this in terms of like an actual product or useful piece of software.
Sorry, I've got a project on the brain.
Yeah, I imagine so.
What language are we working in?
Perfect. So we can say like, for step 1, is the language important? So in the context of like a whiteboarding interview, that might be, pick a language you're comfortable with. It could also be like pseudocode it. That's the thing you'll hear a lot. Pseudocode is stuff that has logic to it, has the shape of programming, but you're otherwise just using regular human words. So you might say, loop through this thing, and for each one of them, do this thing, rather than array.map, like specific programming kinds of implementations of that. You're talking through the concepts. That's pseudocode. Cool. What other clarifying questions might we ask?
What are we going to do with this string once it's reversed?
Okay. Okay, what are we going to do with it after? What else?
How do you want it returned?
Bryce.
How do you want it returned?
Clarify.
Like console logged, printed out.
Okay, what else?
Can I use that?
TJ.
I guess it kind of leapfrogs up the first question, but like, is there an inbuilt method in that language that does this problem already or gets us most of the way there?
Sure. The answer to that's almost always going to be no, but you sound really smart by asking, because that's a real work harder, work smarter, not harder thing. Is like, all right, if I'm using JavaScript, can I just do .reverse? So the answer is yes. It's like, cool, on to the next question. They'll almost always say no, but you'll get points for recognizing that to begin with. Other questions that we could ask?
Is it a fixed length string?
Ooh, how long is the string? Because we could be dealing with strings that are reasonable, 3 characters, 12 characters. It might also be 1,000,000 characters. You don't know if you don't ask. And those might have very different implications.
Do you want to reverse the whole string, or do you want to just reverse each part of the string if it's multiple?
Thank you. Reverse the entire string or the words in them. Very nice.
What type of characters are in the string?
Sure. Any others?
How is it being received?
Clarify.
Are we receiving the string as part of an object, or are we just receiving a string?
Cool. So as you're asking these questions, you're better understanding what they're looking for. Another one I'd probably throw in here, like any memory or speed constraints. Or should I optimize for memory usage, or should I optimize for speed? That'd be a pretty good question. Which might also be like, what are we going to do with it after? Like, it's kind of related to that. That's part of the why of this. But we're starting to get a better idea of what this actual problem is and what the boundaries around it are. Another thing that's doing is it's buying you time. You have one thread working on, all right, I'm asking these questions, I'm understanding the problem. Then in the back of your head, if you're doing this in like a whiteboarding interview, that's also like letting you go through your Rolodex of solutions and that kind of stuff. So I spent a little bit of time figuring out what's going on with the problem. I think this is technically part of step 1, but I'm going to call it step 2 because this is maybe the most important part of this. For devising a plan, make an IO table. Always, always, always. So we're trying to write a function that reverses a string. So what you want to do is say, all right, so you're telling me that if I give you cat, I should get back tack. If I give you race car, I should get back race car. But like you might also say, like for this particular one, let's say it's capital letters. Should that be race car that way and then race car that way? Do we keep the same character or do we keep the position? For this, like Liz, this particular problem, it's almost always going to be like this, but gives you a chance to clarify. You might do something with spaces. Like, all right, or nothing. If I give you nothing, I should get nothing back. The reason that's worth clarifying is like, all right, what if I put in nothing? Does it error out? Or do I just get nothing back? A single space. Like you want just a couple relevant examples. Each one of them should like test something a little bit different. And then part of our devising a plan. So this is how we know we're done. But we go, all right, well, what are all the different ways that we could reverse a string? So somebody mentioned dot reverse earlier. So some inbuilt thing. What are some other ways you can reverse a string?
You could use a for loop.
Okay, and then what do you do in the loop?
Like pop and push into a new array or something.
Cool, pop and push. It's a great way to do it. Other ways we can do it?
you could split it into an array and
Mhm.
then iterate through that array starting at the end, and probably using some sort of pop and push
Mhm.
similar.
Cool. What else can you do? This is one that nobody like thinks of unless they've solved this problem a few times. We'll call it an in-place reversal. And it has to do with finding a pivot character on there and then swapping positions. So like if one of the constraints on this was that it needs to be super memory efficient, you don't have to make an extra string or an extra array or anything if you're doing the in-place one. You're just reversing it like bit by bit on the exact same string. Okay, so we got a couple options here. This is the main goal of step 2. Make an IO table. Just dream up some different ways that you could do this. And then in a whiteboarding interview, you might come up with some like pros and cons of each one of these. You're like, all right, well, this one is super memory efficient. But if I've got lots of memory, this pop push one's probably the simplest. So you're going to pick one of your strategies and you want to justify it with something. So step 3, we're going to execute the plan. And those of you who've done like Whiteboarding Wednesday or the morning exercises, what's the most important part of working through your plan? Don't go. Anyone? Don't go dark. Going dark means that. Talk the entire time. If you make a mistake, if you work yourself into a corner, you should be saying that. But you want to like, and it takes some practice. This has nothing to do with programming. This is like a party trick. You need to get some practice with verbalizing your thought process out loud as you're thinking. It's just one of these. You can do it with some practice, but you want there to be basically no filter between your thought process and what you're saying out loud. And like the mistakes are completely fine as long as you're talking through them. All right, so we're gonna do like a pop push kind of thing. So I'm gonna demonstrate how I would handle this. Okay, so I'm going to do this kind of pop push strategy. So if I have some function that takes in, so I'm going to call it reverse, and it takes in some string. And my goal is to return a reversed string. And so up here, I'm going to say reversed string is just an empty string right there. So really what I need to do is figure out how I get from here to here. So one thing I could do is say I make some like temp array like that. And then I need to turn the string into an array. So I'll say something like reversed string equals string to array. And then what I need to do is for each character in reversed string then we want to pop off the last character, and then we want to push it into the temp array. We'll say pop character push to temp array. Something like that. And then last step, I need to join the characters of that array back into a string. So I'll say like reversed string equals temp array joined. Cool. So there's my step 3. So if you just do this, you probably already failed the interview. What you want to do next is go back to your IO table and use your input output to prove that you're right. All right, so we're trying to turn cat into tack. So let's go back over this. Cat gets pushed in. I have this empty string here. I have this empty array here. And I say the reverse string is the string to array. So that gives me C, A, T. Cool. For each character in the reverse string, I want to pop the character and push it to the temp array. All right, so like this is a thing that I need to clarify, because if I'm doing it for each character in a row, that kind of doesn't make sense. Really, it's not for each character in the reverse string. I'm going to change this now. To like I'll change it to a while. I'll say while there are characters in the string. While there are chars in reverse string. All right, then I want to pop the character and push it to a temp array. So popping comes off of the end. So I'll take that T and I'll push it to temp array. So I end up with T. And then do I still have characters in the array? So that's CA now. There are. And so I pop off the A and I end up with T, A. Oh, cool. Are there still characters in reverse string? There are. It's just the C at this point. So I pop that off and end up with T, A, C. Okay, so now I have this array. Now the last thing I'm trying to do is turn reverse string into whatever this temp array is, which is this, joined. So that should give me a string that says T, A, C. I return that out of the function, and does that match my output? It does. That's the reflection process. And so you could keep going through these if you want. Like if we do the no string one, or the empty string, I mean. So an empty string gets passed in. Reverse string is an empty string. Temp array is an empty array. We turn the string into an array, we end up with an empty array. So you go, while there are still characters in reversed string, well, there aren't. So we skip all of this. And then we turn reverse string into like that thing joined, and we end up with an empty string. We return it. Was an empty string what we were looking for? It is. So if you're doing this in an interview, you can ask them if they want you to go through the entire IO table. I'll also say that about half the time, you're going to find an error working through this process. It's one of the reasons it's like non-negotiable, have to do this. Because making an error in this is not a problem. Not catching your error is. So this gives you an opportunity to find that. And that's the reflection process. Another thing that you might do in reflection is, all right, critique your code. You can go, all right, so this works, but it is memory inefficient because we have to make those temp variables. So if that were a constraint on here, I'd probably do something like in-place substitution. Or you could say, I see some opportunities for improving this, like I'm calling this reverse string, but really like I'm turning it into an array. So I'm using two different data types there. I don't know if that's great, but like that's the other thing that you're doing in reflection. And sometimes they'll go, cool, fix that. You go, ah, shit. So then you go back to the beginning of the process. You go, okay. So just to clarify, you want me to do a string reversal with in-place substitution now. Okay, cool, that's it. All right, so I'm still using the same IO table. Should get the same results, right? Yes, that's true. So, all right, you start working the problem all over again. But your first solution should be probably the one that you feel the most confident that you can pull off. All right, that's the whiteboarding process. Verify the what and the why, devise a plan, execute the plan, reflect. Ask me some questions.
In whiteboarding interviews, are they usually okay with that sort of like agnostic code that you were writing?
Yep, it's called pseudocode. It's pretty standard. And you can structure it a little bit more than this. Like if I look at pseudocode. Like pseudocode just kind of looks like this. I don't super like when they start using this like C syntax style shit with for loops and stuff. That was a pretty good one. This one here, repeat until each other node. But yeah, this is pretty normal stuff. Other questions?
Kyle, are you asking your interviewer any questions to try to get a read on what kind of response they're looking for before you begin?
Absolutely. That's the clarify the what and the why part. These questions are helping us figure out what they're looking for so we don't go running off in the wrong direction.
Is whiteboarding mostly for interviews or in more practical code?
There are two different kinds of interviewing. The thing that I just walked you through is mostly for interviews.
Okay.
I also live and die by whiteboards. My desktop is a whiteboard. I have 3 whiteboards I can see in my office right now. And this problem solving process is a great way to approach problem solving more broadly. The like don't go dark and the like kind of performative aspect of that, that's really just for interviews. It's so other people can see inside your brain, basically. But going through these steps, trying to figure out what you're actually looking for. I'll give you an example. So this is like a Sudoku solver that I've been working on. But to start with, all right, if I pass in something of the wrong size, it should throw an error, right? If it's some of it's the right size and some of it's the wrong size, that should throw an error, right? If I give it this puzzle, it should look like this. I'm still really going through that process. I'm just doing it more in code. All right, if I come up with a really easy thing, just a 1x1 Sudoku puzzle, can it solve it? What if it's 2x2 and there's only one piece missing? Can it do it with a column missing? Can it do it with a row missing? It still really is the 4-step polygon process. By the way, right now what I'm stuck on is it can solve a puzzle with a lot of piece missing. It can't solve a solvable puzzle with almost every piece missing. So that's where I'm at on that right now. Other questions? All right, so we didn't get to the application part of this. So I'm thinking, oh, is it Thursday? I think it's Thursday.
It is.
It is.
Ah, fuck. All right, we have a guest speaker tomorrow morning. Monday or Tuesday next week, we'll do a whiteboarding warm up. It'll be good for everybody. Okay, I got to go to my next lesson. Thank you, everybody. Hopefully that was helpful.